Hello friends, we are going to see the calculation of power in three-phase balance load. If a reactive power is given, the reactive power is given, that is 15 kV VAR, and the power factor, that is zero point 0.1, 0.8 is given to us, and we need to calculate the voltmeter reading, that is 2 voltmeter reading. We have to calculate W1 and W2. Okay, so the first thing we need to understand is what is given. The reactive power is given. The reactive power is Q is given, and it is given in the unit. This thing is very important because if the reactive power is given in some kilo watts, or it is given in VA, so you have to convert it to the VAR. Okay, so as it is given in VAR unit, so we don't need to convert this reactive power. Okay, uh, so we will start our solution directly. Okay, so we will start our solution from calculating W1 minus W2. Okay, we need to find this W1 minus W2, and it is found by using reactive power, and the reactive power is given as Q is equals to 15 K. K can be written as 10 raised to 3 over root 3. So this will give me W1 minus W2, which is found to be 8660.25. Okay, so I get this reactive power. I get this difference of voltmeter 1 reading and the voltmeter 2 reading, that is 8660.25. After that, we need to use this power factor, and we have the formula to calculate a power factor, and that is uh, mm, okay. So the power factor, before finding a power factor, what we need to find is phi, that is cos phi is given 0.8. So we need to find this phi by taking cos inverse to this side, that is phi is equals to cos inverse of 0.8. Okay, and the cos inverse of 0.8 is nothing but 36.86. So the phi is 36.86, and our formula to find W1 plus W2, to find W1 plus W2, that is first step, and this is the second step. We use tan phi is equals to root 3 W1 minus W2 upon W1 plus W2. So we have a phi, the value of phi, which is 36.86. Okay, and we just put that tan phi is tan of 36.86, which is going to get 0.75, and which is equals to root 3 W1 minus W2 upon W1 plus W2. Now this is the matter of only solving a simple equation. We take this W1 plus W2 to this side and multiply root 3 with both the elements. So we get 0.75 W1 plus 0.75 W2, and which is equals to root 3 W1 minus root 3 W2. Now to take W1 and root 3 W1 and 0.7 W1 to one side, and what we get is like this: 0.75 W1 minus root 3 W1, and here we get minus root 3 W2 minus 0.75 W2. So calculating this, that is root 3 is root of 3 is 1 point minus 0.75, which gives us minus 0.982 W1, and which is equals to addition of this 2, that is root 3 plus 0.75, which gives us minus 2.482 W2. The minus minus sign get cancelled, and we get the relation of W1, which is equals to 2.482 upon 0.982 W2, and divide by 0.982, we get W1, which is equals to 2.527 times W2. So we get this relation which is required to calculate W1 and W2. This is equation 2. Now put this equation, that is value of W1, in equation 1, and we will get a W2. So putting in equation 1, and what is equation 1 is W1 minus W2 is equals to 8660.25. So putting this value of W1, that is 2.527 times W2 minus W2 equals to 8660.25. So subtracting W2 and from 1, we will get 1.527 times W2, which is equals to 8660.25. Therefore, W2 is equals to 8660 8660.25 divided by 1.527, and we will get W2 as 5671.41 watt. Similarly, by putting the value of W2 in equation 2, we will get a W1, and putting W2 in equation 2, we will get W1 is equals to, it is W2 times 2.527, and that is equals to 14331.66. So these are the readings of voltmeter 1 and voltmeter 2. Thank you.